Finally, let's go over the burn and liquidate cases. We're going to go over both at the same time because they share a lot of checks. As you can see, we have the check burn amount matches collateral datum in both the burn and liquidate cases, and that check burn is negative in both burn and liquidate cases. So the only thing that changes is this check that in the burn case, you have to be the collateral owner, and in the liquidation case, we have to check liquidation. We compare the relationship between the collateral locked and the amount of stablecoins minted with that collateral. And if that's below the threshold, you are allowed to liquidate that person. If not, you're not. When we liquidate someone else's collateral. That's why here we don't check for the collateral owner, but here we do. So let's go over the first check. Check burn amount matches collateral amount. This is pretty self-explanatory. We collect the datum from the collateral and check that the opposite, this negate, changes the sign. The opposite of the stablecoin amount in the datum is the same amount that we want to mint. Remember that in this case, minted amount is negative because we are burning. So in this case, we want to make sure that we are burning the same amount that it was minted in the previous transaction when that collateral was locked. And to get the collateral input datum, let's go here. And as you can see, we use the parse collateral datum, the same function we used before. But in this case, instead of providing the output, we provide the input, because when we create the UTXO at the collateral's address, we care about the output when we mint. But when we unlock the collateral and burn, we care about the collateral that goes in. So we take this collateral input that goes in and take the datum from it and try to parse it with the function we've defined before. And to get that input, same as for the oracle's input, is the same structure. The difference lies right here. In this case, we are getting the inputs, not the reference input, because we are consuming this collateral UTXO. And we compare it to the collateral validator hash instead of the oracle validator hash. We go back. So that's how we extract the collateral input. We parse it. And once we got the datum and we are sure that the datum has the correct structure, we can compare the stablecoin amounts with the mint and make sure that we are burning the same amount that it was minting before. And that's how we check the burn amount matches the collateral datum. And we do the same for the liquidation, because we also have to make sure that we are liquidating the same amount it was minted. Then in the burn case, we check for the collateral owner. This is same as always. We use this transaction signed by. The difference is that we use this collateral input datum we just got and make sure that the collateral owner inside that datum is the one that signs. So when we burn, the only person that is able to burn that collateral is the person that is inside the datum of the collateral we want to unlock. And finally, in the burn case, we have this check burn negative that is also in the liquidate case. This check burn negative, it's pretty self-explanatory. We take the minted amounts, same as we did here for the check mint positive. We take like the same value, but this time we want to make sure that this value is negative, not positive. We do this check for a specific potential vulnerability. If we don't do this check, someone could send a UTXO without minting. Someone could just send a UTXO to the collateral validator address with a negative minted amount. And because in the check burn amount collateral, we're just checking that the collateral stablecoin amount in the datum is the opposite of the minted amount, a bad actor could use this vulnerability to mint arbitrary amounts of stablecoins without locking. And finally, the last check that we need to go over is the check liquidation. That is similar to when we mint the check max mint out. Well, it's pretty much the same. If we go to check liquidation, we see that we use this max mint and we pass the collateral input amount. In the previous, when we checked for the maximum mint, we provided the output because we were creating an output in the collateral validator address. But in this case, we are consuming. So we provide the collateral input amount using the same functions we used previously. And we check that this maximum mint is smaller than the minted amount because we are liquidating it in this case. The minted amount is negative. So when we negate it, we get the positive amount of stablecoins we want to burn. And if that amount is bigger than the maximum mint, that means the collateral is below the threshold and we are able to liquidate that position. This comparison makes sure that if someone has the correct collateral for the stablecoins they minted, you cannot liquidate that position. But if they don't have enough collateral, this will make sure that you can. All these two burn and liquidate cases work in tandem with the collateral validator script. So in the minting script, it was just the minting script, these three cases that we need to pass. But in the burn and liquidate cases, these are not the only ones. These have to pass, but also because we are consuming a UTXO from the collateral validator, that the collateral validator also has to succeed. So let's take a look at the collateral validator. Luckily, it's super easy compared to this one. In the case that we want to burn in the minting policy, is the case that we want to redeem in the collateral. As you can see, the collateral redeemer can be either redeem or liquidate. In the case we are burning in the minting policy, we are redeeming in this validator. And in the case we are liquidating in the minting policy, we are liquidating in this validator. The checks are super simple. Actually, I think the entire validators fits in here. Yeah, that's it. So here's the whole validator. In the case we want to redeem, we just need to make sure that the owner of the collateral is the one that is signing the transaction and that the stablecoin amount is the same we previously mint. This check is the same we did in the minting policy. The difference is that this check is to unlock the collateral and the other one is to burn the stablecoin. If we only do this check in the minting policy, the owner could just unlock their collateral without paying back the stablecoins. And finally, in the case that we are liquidating, is just make sure that the amount that we are burning is the same as in the datum. We don't check for the owner because we are liquidating someone else's position. Now, let's see how we can burn and liquidate in the off-chain code. If we go to the stablecoin, here we have a single function called burn or liquidate because when we build the transaction, there's a little difference between both cases, so we can just use a single function. We make a bunch of checks. These checks are just making sure we have all the values in our local state. If you happen to not have all these values, you can just go to the Explorer or just query them from the node. It's not part of the off-chain code, it's just the UI. Now that we have everything, we console log the amount that we are going to burn or liquidate. We get our pub key hash from the current address. Here we use this burn or liquidate boolean that changes when we select the radio button in the UI. So if we select burn, the collateral redeemer is going to be redeem. If we select liquidate, the collateral will be liquidate. And in the minting case, if we select burn, the mint redeemer will be burn. And if we select liquidate, the mint redeemer will be liquidate. And as you can see, if we go to collateral redeemer, I think we didn't saw this one. Collateral redeemer can be either redeem or liquidate. So here we are. Now that we have our PPP hash and our two redeemers and everything we need, we build the transaction. We create a new transaction. This transaction reads from 3 different UTXO. We use the oracle as reference input, the collateral as reference script, and the minting policy as reference script. We collect from the collateral UTXO because we want to get that locked collateral. And we provide this collateral redeemer that we just chose before. Then in the same transaction, because we are collecting from the collateral UTXO, we have to burn our stablecoins. For that, we provide the asset class of the stablecoin and the amount to burn as a negative value. And here we also provide the redeemer of the minting policy. Finally, we add the signer's key, our signer's key. In this case, it is not necessary for the liquidate case, but it is for the burn case, so I can just add it in both cases and that's it. If we are liquidating, no one will check the PPP hash. Finally, we balance the transaction. This native untyped Plutus core is just a flag to change which compiler you want to use to check the validators locally, but you could just remove this and it's the same as before. So we sign the transaction and that's it. As you can see, like this is the whole thing, as same as before. We need to use the reference, but now because we are not just minting, we are also collecting. We have to use the collateral reference script and we have to provide the correct redeemer. And of course, the correct amount to burn or liquidate. And there you go. That's both the on-chain and the off-chain code of our stablecoin. I hope you like it, but stick to the homework so we can discuss the limitations and improvements we could make to this stablecoin.